Welcome back. Now we've seen what happens when we add an actor world offset or set actor location with and without sweeping. We've seen that we have to have sweeping enabled for two objects to block each other. Now, on the other side of the room, starting with the panel labeled 4, we have actors that are moved using a different method of movement. If I right-click on this actor and I browse to it, it's called BP Ball Add Force. And we can see in its start moving function, as soon as we set should move to true, we're now calling add force. And add force is being called with the target ball mesh, and we're adding a specific force to the ball mesh. Now, a force is a vector. It has a direction and a magnitude. That direction is the actor forward vector, but we're scaling that vector by a force magnitude. And as you can see, it's quite a large number here. Adding this force requires the ball mesh to simulate physics. So if we select our ball mesh in the blueprint and we take a look at its collision presets, we'll see that it's set to physics actor. Now this is a preset that has collision enabled, set to collision enabled query and physics, so it can simulate physics. Its object type is physics body, and its collision responses to all channels is block. And we can scroll up to see in the physics section that simulate physics is checked. So this object is simulating physics. And we can also see that enable gravity is set to false. So these objects are not using gravity. So we can use these presets. We don't have to set this to default. We'll just use the physics actor collision preset. And when testing, it's always a good idea to verify that each instance in the level is using the collision presets that we expect. So I'm going to select the first actor to the left with ball mesh selected in the components. I can scroll down and see that its collision presets is set to physics actor. And the same goes for the ball on the right. If I select its ball mesh, it's using physics actor. And both of these are indeed simulating physics, as seen by the checkbox for simulate physics. So we're adding this force. Let's see what happens when the objects come into contact. And as we can see, the objects bounce off of each other. So they don't just stop, they actually bounce and fly back in the opposite direction. And this is a result of using physics. You see, adding a force sends the object flying in the direction of that force vector, and then hands off the movement updates to the physics system. So this collision was not using the query system. In fact, we can change the collision settings so these components are no longer even using the query system. How do we do that? Well, we can change the collision settings. Now, we can change it per instance, we could change it on the actor, or we can go back and change it on the ball mesh itself. If we want to use that ball mesh static mesh asset collision settings, then our blueprint has to change collision presets to default here. And then we can change the collision settings on the static mesh asset SM Sphere 30. So let's go into SM Sphere 30 and change collision enabled to physics only, no query collision. Now this static mesh asset is not using the query system. It's only using the physics system. So back in BP Ball Add Force, we'll just double check collision presets is set to default, and we'll double check on instances in the world. We'll select this one, select its ball mesh, go down to collision. We see that its collision presets is set to default. Same goes for this one. Its collision presets is set to default. So we're using the collision presets on the static mesh itself, which is using physics only for collision enabled, no queries. So let's press play. And we can see that our collision was detected. The physics system imparted those bouncing forces, which is awesome. So as you can see, when we're setting the actor's location directly, or the component's location directly, we have to use sweeping to detect collisions. But when we're adding a force, we have to use physics. And the physics system will detect those collisions. And in fact, cause the objects to bounce off of each other, which gives a little bit more of a realistic feel for our collisions. So there are two different types of calculations being performed: query calculations and physics calculations. So on the other side of the room, we were using the query system, and over here, we're using the physics system. And it's important to understand that, because if you go into your collision settings and you change your collision enabled to one of the options that does not use physics, such as query only, well, now we have a problem, because we're using add force on an object that's collision enabled is set to query only. It cannot use physics. In fact, we cannot even simulate physics on this ball mesh because its collision enabled is set to query only. So simulate physics does not make sense. And if we go and try to play test this, well, we may not get the results that we expect. And as soon as we press stop, we get some warnings in the message log. We see that this SM sphere is set to simulate physics, but collision enabled is incompatible. And we get multiple errors because there are multiple actors in the world using this particular SM sphere 30 mesh, which are trying to simulate physics. We also see that this sphere has to have collision enabled set to query in physics or physics only if you'd like to add force. So there's two problems here. One is we're simulating physics, and that is not compatible with the collision enabled setting. And the second problem is we're trying to add force when the collision enabled is not configured properly for physics either. So changing this to query only is a mistake. So we can change that back to either physics only or collision enabled query and physics. This also uses the physics system. And notice there are two other options: probe only and query and probe. If we set it to probe only and we go and press play and just wait a second, we'll see that we don't get those collision interactions because probe is going to detect when two objects hit, but not import physics forces as a response. They will not bounce off of each other, but callbacks such as on component hit will be triggered. So probe is sort of in between fully using physics and not using physics. It's capable of detecting physics interactions, but not imparting resulting forces, such as making objects bounce. So we'll go ahead and set that back to physics only, no query collision, and just play test one more time to show that now we get that bouncing, and that is because of the physics system. We are not using the query system at all, so we're not using sweeping. We're using a completely different system for detecting those collisions. Excellent job. In the next video, we're going to see what happens when we move objects in yet another way, and that way is by using a projectile movement component. So we'll do that next. I'll see you soon.